Good evenings, ladies and gentlemen. I am Professor Min Zone from the University of Ngata Minigala. So today we want to talk about tidal energy. So what is tidal energy? Tidal energy is the conversion of the kinetic energy of the tides to electricity. So the way it works is that much like a wind turbine, tidal energy utilizes turbines that would spin depending on the strength of the tide, and we will convert that mechanical motion to electricity. So what makes tidal energy renewable? Tidal energy is a renewable source of energy due to constant change in tide throughout the day, high tide and low tide. And this is predominantly caused by the gravitational force of the moon. Now that we've demonstrated what tidal energy is, I would like to take you guys back into my laboratory and demonstrate how it really works. Hello everybody, welcome to my laboratory. And if we move over here, I will demonstrate how it works. So if we look at this sink here and this turbine, so the sink right now is filled with water, indicating that it's high tide right now. And so when it wants to get back to low tide, I'm gonna drain this water out here. Watch me drain it. The water is gonna leave the shore. And so when it's falling back, the turbine is gonna spin due to the movement of water. Likewise, when it wants to go back to high tide, the turbine is going to spin also due to the movement of water. So this means that the turbine is spinning every day, all day, every day, throughout the day, and generating electricity. As for what undergoes behind the turbines are connected to a gearbox, which is also connected to the generator. So as the turbines spin, the gearbox is going to follow its motion, and the generator is going to rotate, and it's going to spin the electromagnets inside the generator, and it creates a lot of currents and therefore electricity. Excellent. Now that we know what tidal energy is and how it works, let's talk about how it's produced. First off, we have tidal barrages. So it's much similar to that of a hydroelectric dam system. Tidal barrages are one of the most efficient ways of harnessing tidal energy. This form of tidal energy requires a dam that forces the water to flow through a miniature hole where the turbine would be located. And so this makes the water speed much more higher as a heavy body of water is flowing through a miniature hole, and so which would produce much more kinetic energy, thus more electricity. Great. Now next up we have tidal turbines. This is another variation, but the functionality is similar to that of a wind turbine. So much like how a wind turbine would work, people would place simple turbines in the water where the water would flow and spin the turbines. And this is a much more simple and cheaper installation, but the trade-off is that it produces less energy compared to other designs. Good. Now, lastly, we have tidal fences. Now, tidal fences have the same design as tidal turbines, but with different turbines. It is equipped with a vertical spinning cylinder-shaped turbine, which is more susceptible to follow the motion of water. So theoretically, it should spin much more and generate more electricity compared to normal turbines, normal simple turbines. Now that I've stated what needs to be said, my friend Hainsey Du would like to carry on with the presentation. Carry on, my friend.
Hello everyone, my name is Professor Hainsey Du from Hoge University. So some pros of tidal energy. It's clean and renewable. Not only is tidal energy renewable, it's also clean as it does not emit any gases or does not necessarily take up a huge space if compared to other renewable energy sources. For example, Sihua Lake Tidal Power Station was built along a 12.5-kilometer long seawall, whereas one of the largest solar farms took up to 43 square kilometers of land. Tidal energy is also predictable and reliable. Gravity from the moon and sun creates tide waves that help create tidal energy. So as long as the Earth is rotating and the moon is orbiting Earth, there is no way tides will cease to happen. This alone helps tidal energy to be on the upper hand of wind or solar energy that relies on the weather. Because tides are easily understood and trackable, it's very easy to predict tidal patterns, which allows businesses that uses tidal energy to use tidal barrages, tidal turbines, and tidal fences to produce electrical energy from tidal energy. Long-lasting equipment. It's a long-lasting equipment since tidal energy systems have a very long lifespan of around 75 to 100 years of working use. If compared to other renewable energy sources like solar panels, they tend to degrade after about 25 to 30 years. It's also effective at low speeds. Tidal energy systems operate even if the water passing through is extremely slow. Water is 1,000 times denser than air, which means tidal energy systems could still be powered even if the water passing through is extremely slow. So, some cons of tidal energy. It has a very big impact on environmental. Since tidal energy resources demand a turbulent water to power them, it can easily destroy a lot of sea animal habitats, especially tidal barrages that uses dams to turn kinetic energy into electrical energy. Uses a lot of space that can damage movements in sea life and can even cause habitat destruction. It also has a high construction cost. Building tidal energy resources takes a lot of maintenance work and additional fees because the structures must be able to withstand any type of corrosion of deep sea water. Even though with its extremely long lifespan of ranging from 75 to 100 years, governments are concerned about the 5-year budget, which is annually about $105 million. It also has a very scarce there's a scarcity of suitable locations. Some companies that use tidal energy resources for electrical energy have made the mistake of planting tidal energy structures in the wrong place and have experienced very slow and low energy from tidal resources because of it. They require a very specific set of factors in order to properly and efficiently run at full power, or at least to be able to produce enough electricity from tides. It can also Tidal energy can also be extremely inconsistent. Since tidal energy structures will be built deep underwater, there will be a lot of turbine failure rate. It might not be able to produce enough electricity when faced with slow water passing them, or uh, it might not be able to operate properly if faced with extremely strong currents. Some facts about tidal energy and tidal energy structures would be that Megan tidal stream project. It's one of the most successful full-scale tidal energy farm currently being operated in Scotland. Began construction in 2015, but actually started running in 2017. Over the past 2 years, this tidal energy farm has produced 17 gigawatts per hour of clean renewable energy. The project currently powers an approximate 100,000 homes. The tidal energy farm uses massive 49 feet tidal turbines with 52 feet long blades that spin as the tide passes through them. The farm has been very successful because of the powerful tides in the area. Scotland has very promising and suitable locations for tidal energy structures. It has 25% of potential offshore wind and tidal energy resources for the entire European Union. This is what makes the Majan tidal stream become one of the most successful tidal energy users in the world. Next up is Shiwa Lake Tidal Power Station. It is one of the largest tidal energy farms in the entire world and can even be seen from outer space. This tidal energy farm wasn't even built to be a tidal energy station when it was under construction. It states that the project was originally intended for the reclamation of land and to provide desalinated water for agriculture. However, once construction was completed, the water within it soon became polluted, stagnant, and unfit for use. This forced the government to rethink its plans and find a use for the tidal lake while also helping the ecosystem within it to recover. Then they later thought of doing tidal energy because of the strong currents that go through the tidal. The tidal power station became operational in 2011 and currently produces 550 gigawatts per hour annually. with a capacity of 254 megawatts. Even though it is said that tidal energy structures would have a big impact on marine ecosystems, they built a tidal barrage. Even though it is said that tidal energy structures would have a big impact on marine ecosystems, Company attracts tourists due to it being the longest tidal barrage, and also because of the lively marine ecosystem that's living right beside it. Thank you.